Hi, Veronica. This is this is me. All right. So solving this type of equation, there was no, there is references to this, um, but not exactly a problem like this. Okay, with the fraction involved. Basically, you have to draw from the concepts of, um, using clearing the fraction. Basically, that's what it is. Okay. So the first thing, every time you have any type of equation, whether it's linear, quadratic, higher polynomials, and so on, right? If you want to solve or simplify, then you clear out the fraction because you don't want to deal with the fraction, right? So in this case, right, you want to clear out the fraction, so you find the LCD, the least common denominator. In this case, you look at 3, you can look at 9, and obviously 9 is your least common denominator, right? We know what to do with this. We're supposed to. We're supposed to multiply all the terms by the LCD, right? So you multiply by 9, you multiply by 9, you multiply by 9, and you multiply by 9, all right? So that's just to, how do we say? Um, get rid of those denominators. Okay, so here 9 times p squared, right? So there's nothing canceling out here. Here you have 9 divided by 3, gives me 3, so I have 3 remaining. 9 divided by 9, you have 1 remaining, and here 0 times 9 is going to stay at 0. So when I rewrite my equation, which is equivalent, it's going to be 9p squared minus 3 times 4, 12p, and then plus 1 times 4, 4, equal to 0 times 9, 0. Okay, so now you have a trinomial, right? And then you can factor this, right? So let's say if we can factor this, we, uh, if you want to use the AC method, you can use the AC method. Why not? So that's what I taught in the videos, my previous videos. So AC method means that this is A, this is C. You multiply them, you get 36, positive 36. So therefore, I need to break this down into two factors that's going to be equal to negative 12. Well, clearly, it has to be negative 6 and negative 6, right? Because negative 6 times negative 6 is negative 12. And negative 6 times, well, sorry, let me repeat that. Negative 6 times negative 6 is positive 36. And negative 6 plus negative 6 is equal to negative 12. Okay, so it satisfies both situations. Now, you bring down the negative 6 and you put a p here for the negative 6, and you put another p here, negative 6, right? You add them up. These two terms is going to replace negative 12p, right? So this term here is going to be replaced by negative 6p plus negative 6p. So that's what we're going to do here. So it's going to be 9p squared minus 6p plus 4 equal to 0. Okay. If you remember, if you have 4 terms, you need to factor by grouping. So we factor the first 2 and we factor the last 2. You can see that here I included the negative. All right, so once you group, then you factor within the 2 groupings, and you're expecting whatever is left inside the parentheses to be the same on both sides. All right, so here 3p is your common factor, so it's going to be 3p here times 3p minus 2. And then here, I want to make sure that I get 3p minus 2 inside the parentheses. So instead of factoring just 2, I'm going to factor out negative 2 because that's the only thing that's going to give me 3p minus 2. So factor out the negative 2. And then you're left with 3p, right? Negative 2 times 3p is negative 6p. And then negative 2 times negative 2 is positive 4. And then you're assuring that these two are the same, equal to 0. Now we can factor out that 3p minus 2, right? That's my factorization here. And then whatever is left, and whatever is left is the 3p minus 2 again. It will be in the other set of parentheses, a equal to 0. They just happen to be the same. And then each factor is going to be equal to 0, but since it's the same, I don't need to do that twice. It's just going to be 3p minus 2 equal to 0, 3p equal to 2. Therefore, p is equal to 2 over 3. And that's your final answer. So your solution is 2 over 3. Okay, so I hope this was helpful. I think it should be helpful for that problem. All right, that's it.